Good morning, everyone. I'm very happy to launch this discussion with all of you today to talk about a big stake in EV industry, about how to manage knowledge with AI. First of all, to start the discussion, Alain, can you first just remind us what is this project ITER, and tell us what is the big challenge and how AI can help you in your project?
Thank you, Alexandre. Yes, so good morning, everyone. ITER is the largest research endeavor, largest research project in the world, international one. We are gathering basically half of the world population towards one project, which is the demonstration of feasibility of a nuclear reactor based upon fusion reactions. This is a very big endeavor. This device is hosted by an international organization on the French soil at the north of Aix-en-Provence. It's called Cadarache, and is being built at the moment and will be operating, let's say, in the next decade. The big challenge for us is that this project is extremely complex in terms of number of people interacting, number of companies, number of actors in this project. The long time duration, this project has been prepared already for more than 30 years, will be operating another sort of 30 years. So we have a problem of transfer of knowledge between the various teams. In time, in space, with all our actors, the transfer of know-how and know-how not to our stakeholders, because the goal of this project is to demonstrate the feasibility of this kind of reactors, and then for our members to build them. So we have this extremely complex challenge to manage a very complex knowledge.
Thank you. Sabine, Airbus is a well-known company, but of course knowledge management is a challenge. Can you tell us how and why it is so complex in your context?
Yeah, thank you. Thank you for the question. Airbus has a wide range of products, and we are, if I'm taking the two biggest challenges that we are facing at the moment, on one hand we have a huge customer demand, and we need to ramp up production, so we really need to ramp up in the volumes that we are producing, so efficiency is a key topic. And on the other hand, we are preparing for the next generation aircraft. So if we want to launch a new aircraft generation, it has to do step changes in technology. It needs to be much more efficient again than the ones that are the best ones today. And it's about long cycles. So last time that we developed is a couple of years ago, and we are in the middle of this generational change. So we have a lot of young people coming, joining us. We need to upskill them, and we still need to actually take all the knowledge that we gained over the developments over the last 50 years that Airbus exists, and make sure that we really take all that data and build on this for the next generation aircraft. So it's a huge challenge to bring all this together and to make sure that we skill up our people very quickly with all the good knowledge that we have in the heads of the people. And that's a core thing. It's about people.
Thank you. Clément, with Ask for the Moon, you are an expert in knowledge management. If you take one step back, can you share what you observe, common main stake, difficulties or challenge you see regarding knowledge management in the industry?
Thank you. Yes, so good day, everyone. We are Ask for the Moon, but actually for our customers, our users, our engineers, we are Ask Airbus, we are Ask EDF, Ask Orano, Ask Vinci, Ask SPI, Ask CNES. So we work with leading industrialists with a huge expertise from the past that also needs to build the future. And our product, our platform, is a way to extend the expertise through time, through space, and through people. And the best would be to tell a story, because then we understand it concretely. For example, at Airbus, one engineer needs to develop a new process for the future aircraft of Airbus. Everything needs to change because we need to decarbonize, but also we need to remember everything we learned in the past. Every mistake that we make, we don't want to make them again. So we want a tool that enables people to be more efficient using the knowledge from the past, understanding their context, and pulling all the knowledge from what has been written in the last 50 years. But you're also building the future. And for ITER, and for Airbus, and for EDF, and for all our industry, we also need to discover new knowledge. So the AI should also be a tool that brings people together in order to extract tacit knowledge. So things that have not been written down yet, in order to continuously develop the knowledge of tomorrow. And that's what AI can bring on the table. Like being an efficient tool for individuals, using the resources from the past, but also building the expertise of tomorrow.
Alain, coming back to the ITER project, so we understood it's a quite complex initiative and project. Can you share a concrete illustration or initiative with AI you have launched to accelerate and support your knowledge?
Yeah, so AI is really being adopted by ITER very recently, officially. There are governments, they have accepted that we inject AI basically all along the life cycle of the project, from the basic engineering, systems engineering, to the construction part, to the preparation of the operation, maintenance, and even later on the commissioning, the construction, and so on. So we have now a strategy which is adopted by our members, and we are now implementing, and the implementation is, of course, subject to the priorities, to the phase of the project we are in. So basically these days, the big priority is given to the constructions, to the support of the construction. It goes, for instance, I mean, we have somebody in the room here coming from our European member who is working with us on the management very soon. Let's say in a year and a half time, we will start welding the various subparts of the so-called vacuum vessel, so the machine itself. This is an endeavor that will take 2 years and a half, 24/7, with 27 robots working in parallel. Millions and millions of non-destructive testings that we have to manage, that we have to understand in order to make sure at the end of the day that this vessel, for instance, is a graded nuclear vessel. This is, I don't want to say impossible, but this is extremely difficult if we don't have an augmented capacity by AI. This is one example. Many, as I said also from the science part of it, the scientific exploitation of ITER will very likely, just like CERN, just like all those big scientific projects, will need a very big support for the modeling and for the data analysis from AI.
Sabine, at Airbus, we know you use AI for customer service, engineering, also to design a new program and craft. Can you tell us a bit more concrete example, especially in a context where safety, of course, is at the top priority of the company?
Yes, actually, yes, we are using AI in all different elements of our company, and we have a quite long history to AI. So I see a couple of colleagues here from the space side. We used AI already in the 19th. Let me give you a couple of examples. If you want to dock in space into the ISS, for instance, we always used to use vision-based navigation. So you need to automatize this, machine learn this. We also use it extensively in all the space images that we are taking and using them intelligently today. But then it's, as you say, it's basically in all areas. If I said we need to ramp up production, the supply chain situation is very difficult. So in the areas of production, you mentioned robotics, but then there's all the workflows and all the kind of processes which are around that, missing parts, knowing exactly where the supply chain stands, being sure that all the different tiers have what they need in order to fulfill what's needed in the next day, is a crucial thing. And AI can massively help here to get along with the data. If we think about then the design of an aircraft, that's really taking advantage of all the testing data that we have. If we are going into new simulations, new aircraft, you take all the data that you have in your back pocket. And it's always about how can we make sure that the models that we create numerically are really actually validated with the physics. So that's what we've done over the past. So now if we want to go into new ones, it's actually extrapolating all this knowledge into the future. And let me give another example. You were talking about that on the aircraft. Of course, we want to use AI as well to make sure that safety can even be enhanced, that pilots can be helped more, that the crew in the cabin can be helped more. So if we look into the cockpit, for instance, think about your car. A lot of things are given to you now that you can take. So calculation of your destiny, where you want to go. A big example for the pilots is actually when they're preparing the flight, they need to talk to the control towers, they need to manipulate. So they have a lot of actually workload in a specific task which is still on the ground. And specifically this talking, you can imagine, you all know all the different accents that we have in English, for instance, around the world. If you can have speech-to-text reliably in the cockpit, this is a big help. So now you all know, now we can automatically translate during the conferences, this is all good. We need to be sure that we are always true. We cannot live with 70% reliable information. You imagine, you once go translate instead of Paris, Prague, you will not get there. So these are things where we, of course, need to certify the things as well. So we really need to be sure of what we are doing. So with all the speed that we can gain from AI, we still need to secure a safe way into certification, and we need to be 100% sure. We cannot live with a hallucinated thing that we need to recover. So these are actually I would think, the royal discipline of AI. When we need to bring it into the aircraft, then there's a lot of services around predictive maintenance when we do customer services, or a lot of these mega searching and efficiency topics that we can have when a customer is calling with a problem. Of course, we want to rely on all the data that we have already from past challenges. And this is possible today, and this is happening. So we have more than 150 projects which are going. Now it's about taking the ones that have the biggest ROI and scale them. And one of the scaling topics is as well, I mean, we don't use ChatGPT with us. We need our own secure environment, but we have rolled out our own LLM actually to 70,000 people in their daily life. So these are very different applications, but all are driven by efficiency, safety, enhancement of product value, and a lot will come more in the future.
Clément, you mentioned a good case in electrical engineering. Do you see similarities, and can you share any concrete progress in that industry?
Yeah, I think a good example is a story from Framatome. So it's about designing the future of our power plants in a very, very secure and compliant way. So one person at Framatome needs to do a modeling. He's a neutronics engineer, and for this, he needs to use models from all over the company. Thermodynamics, mechanics, but he also needs the rules from the safety department, and he needs also the laws from the ASNR, etc. The tool enables him to ask a question and find the answer that will enable him to solve a problem. Because at the end, what we expect from AI is not just to do more knowledge management, it's to turn knowledge into an asset, a capacity to solve problems. So the AI provides an answer, cites the sources, shows the experts that are the authors of the sources. But the AI must be able to also say, I don't know. So instead of hallucinating or pulling data from Westinghouse, the AI should say, here, I don't have the answer. But I know who knows around Framatome, around EDF, around the value chain, and I can find them for you. And this is where AI becomes a way to find the right people at the right time, enable exchanges in a multilingual way, find the authority experts that can validate the answers, and ensure that our modeling engineer has the solution to his problem, so he can do his job faster. In this case, he saved 3 months in his study. because the machine was not here to replace the expert, it was here to introduce him to the right one that could actually at the end say, you are using a model that is 2.5 years obsolete. It will fail, and it will fail exactly in this case. We had to replace it because we failed the safety test later in the value chain. So we pooled the knowledge from later in the value chain and we advanced it. We ensured the continuity between all the people and we actually prevented mistakes in the modeling. But this was not the AI doing the job. It was the AI ensuring that people talk together at the right time and that this exchange is now saved, capitalized. So the next time, the AI will have the answer immediately. It can happen in 1 month, or it can happen in 50 years when the people are not there anymore.
Alain, you previously mentioned topic of modeling. Can you tell us a bit more about interface between human machine, which challenges and how AI can help at the project ITER?
Yeah. So the challenge there is that when this device is assembled, we will have to operate it. So it's a very complex operation. It's a system of systems, hundreds of different systems that are working together. And today, the operation of such device in a nuclear environment, in a totally international environment, requires a lot of care to prepare this operation, to prepare the operators, but also to support them with standard tools and so on. So this is the first part. Then on the scientific part, once this device has given its results, has worked, we need to dig, just like in CERN, just like wherever, we need to dig into the data. There will be billions and billions of data, including images, including a lot of things here. And we need to understand what this plasma, so-called, is telling us. The plasma physics, the magnetized plasma physics at very high temperature is one of the most difficult scientific problems. It's not yet accessible to the high-performance computers. So we need to be clever to understand from the science, fundamental equations, from the observations and so on, what this is telling us, what is the real performance, what is exactly this plasma doing. And this is a matter where AI can really support here. We are now working, for instance, with Microsoft Research, but they are not the only ones, to try to understand what kind of architecture we can put in place in order to mix all the various knowledges we have from the various sources, the theory ones, the experimental ones, all the models that we have developed along the years, in order to understand what exactly is the performance, and later on to develop the real drivers of these devices. Of course, the reactor will have to be driven automatically. You cannot expect that the scientist is always behind telling you, no, you have to do this, you have to do that.
Thank you. Now, looking forward, Sabine, if we project a bit and look at the future, what do you think at Airbus should be done to accelerate data and AI? Or what do you need and how do you see an accelerator?
No, I think I tried to tell it before. So we are in the stage where we have more than 100, 150 projects, but it's now about understanding how we scale them and taking the couple that you can really scale. Because it's not always giving you exactly the result that you think. Not all the POCs and all the proof of concepts are actually bringing the biggest value add. So it's about taking the couple that we can really scale. And the first ones are coming. But I think you mentioned a very important point, which I would like to come back for the conclusion here. It's really about the people. Finally, it's about the people. AI can help us big time. But basically, it will actually change the employees and the knowledge of the employees that we need. So, as I told you, we are taking a lot of young engineers at the moment. We use AI and we use as well our experts to train them quicker. But basically, we need even better trained people to be able to deal with the more sophisticated tasks, because the AI can take the more easy ones. So that's actually the real challenge, is how to take the people with us, how to give them the right environment, and as well how to upskill them quickly enough to be able to face it.
Thank you. And my last question for you, Clément, given the experience and what you have seen on this topic, how do you see the main risk of failure? Do you have any advice or anything to share on that?
So we did fail some projects. And of course, you have compliance and sovereignty and cybersecurity, but these are engineering problems that you can always solve with the right people. At the end, the projects we failed because we didn't have all the value chain of people engaged. And the reason why we didn't have those is because we didn't have value for everyone involved. So if you want to impact a big performance change at scale, you need a product and a project and an operating model that includes your change management. And the best way to do change management very fast is you need everyone, from the frontline worker to the CEO, to see value. And today, you need to see it in less than 1 minute. If you want something that spreads fast, trainings and explanation shouldn't happen. Because the real part or the real place where you want to invest your energy and your time is to upskill people in the way they do their job. You don't want to train them on the platform, on the tool. So what we do to stop failing is we make sure that we find core business use cases that is a pain for everyone along the value chain, and we make sure that everyone saves time very fast, so they learn to use the product and to change their way of working with AI along the way. You don't want to train people for 6 months for AI and then expect ROI in the next year. Because you have so much things to do at ITER and at Airbus that experts, they don't have time for that. We have the experts are not enough. They have very heavy weeks. If they don't save time with your solution on the first week of usage, because you help them capitalize their knowledge automatically, because you help them answer recurring questions without having to repeating themselves, you won't get the expert support. If you don't have the expert support, you don't have the quality, you don't have the pertinence, you don't have the authority, so you have nothing. If you don't have the end users that consume the knowledge and actually use the tool to not make the same mistakes again in a really friendly manner, you don't have the consumer part of the knowledge, so you don't have your value chain also. And if you don't have middle management value, like being able to recognize your experts, being able to manage and pilot your team better, you will have all your middle management blocking the project. So at the end, the question of AI is a question of how do you learn new ways of working at very large scale for these industrial projects. And it means bringing value for every people you need to change. And that's our goal with Ask for the Moon, and I guess that's the goal of my co-speakers.
Okay, thank you very much to all of you. It was very interesting and definitely a big topic which is not closed. So thank you very much for this speech.
Thank you.
Thank you.
Thank you.